Imagine a metal so strong it can survive inside a jet engine, so safe it can live inside your body, and so beautiful it's used in luxury watches worth thousands of dollars. But here's the crazy part. Titanium is one of the most abundant elements on Earth, and yet it's one of the hardest metals to actually make. So how do we turn dull black sand into one of the most advanced materials on the planet? Let's find out. Deep beneath the surface of Australia, South Africa, and Canada, massive machines dig into open-pit mines. But they're not looking for shiny metal. They're really looking for something that doesn't look impressive at all. Dark minerals called ilmenite and rutile. Inside these minerals, titanium is trapped. And that's the problem. Titanium doesn't like being alone. It bonds aggressively with oxygen and other elements. That's why you never find pure titanium just lying around. It's chemically locked away. Extracting it is like trying to steal something from a vault that fights back. Once the ore is mined, it's crushed and washed. The titanium-bearing minerals are separated from unwanted material. But this is just the beginning. Now comes the real challenge. To free titanium from its chemical prison, scientists use something called the crawl process, developed in the 1940s. And even today, it's still the dominant method. Here's where things get intense. First, the ore is heated to around 1,000 degrees Celsius. At that temperature, chlorine gas is introduced along with carbon. The reaction transforms the titanium inside the ore into titanium tetrachloride, a highly reactive liquid. Not metal yet, just a dangerous chemical. Impurities like iron are left behind. The liquid is then distilled, like purifying alcohol, until it becomes extremely pure. But we still don't have metal. Now comes the dramatic step. The purified titanium tetrachloride is placed in a sealed, oxygen-free environment. Then magnesium is added. A violent chemical reaction takes place. Oxygen is stripped away. And what's left behind is something called titanium sponge, a gray, porous, almost alien-looking chunk of metal. It doesn't look impressive. It's not shiny. It's not strong yet. But this is raw titanium. From here, the sponge is melted inside a vacuum furnace using either vacuum arc remelting or electron beam melting. Why vacuum? Because titanium reacts instantly with oxygen. Even a little contamination can ruin it. Inside the furnace, the metal becomes molten. It glows white-hot. Any remaining impurities are removed. Then it's cast into massive ingots, huge solid blocks of pure titanium. Now it finally starts looking like real industrial metal. But we're not done. These ingots are reheated and forged, rolled, or extruded into sheets, rods, and tubes. Industrial presses shape them into usable forms. And here's where titanium becomes special. On its own, titanium is strong and lightweight. But when mixed with small amounts of aluminum and vanadium, it becomes a super alloy. Stronger than steel, almost half the weight. Highly resistant to corrosion, able to survive extreme temperatures. This is why titanium is used in aircraft frames, jet engines, spacecraft, submarines, even prosthetic limbs. Your body doesn't reject it. It bonds naturally with bone. Think about that. A metal dug from black sand, refined through extreme chemistry, melted in vacuum chambers, is now trusted to live inside the human body. That's insane, but titanium has a downside. It's expensive. The crawl process is energy intensive. It's slow. It requires high temperatures, dangerous chemicals, and controlled environments. Compared to steel or aluminum, titanium production is complex and costly. That's why scientists are researching new methods like the FFC Cambridge process, a technique that uses electrolysis to extract titanium more efficiently. If perfected, it could reduce costs and environmental impact dramatically. Because here's the truth, titanium might shape the future. From lighter airplanes that save fuel, to stronger medical implants, to advanced electric vehicles, to deep-sea exploration and even space missions. Titanium is quietly powering modern engineering. And yet most people never think about it. They see the airplane, they see the watch, they see the implant. But they don't see the chemical reactions, the vacuum furnaces, the glowing molten metal. They don't see the journey from ore to sponge to ingot to precision-machined masterpiece. Titanium isn't just a metal. It's a symbol of how far human engineering has come. We took something abundant yet unusable, figured out how to unlock it, and turned it into one of the most advanced materials on Earth. So the next time you step onto an airplane, or see a titanium watch, or hear about a space mission, remember, It all started as dark sand buried underground, and through chemistry, fire, and innovation, we transformed it. That's the story of titanium, and honestly, it's one of the most difficult metals ever mastered.